Hi again, everybody. Right now, we are looking at the more challenging homework problems from chapter 2.6. This chapter asks you to put together the variety of skills that we've learned in this chapter. So I've chosen question 8, A, B, C, and question 11 to answer to help you out. So definitely try these questions first and then watch these solutions. Notice that I've copied out the questions beautifully, and I start from exactly what was in the textbook. That's part of your learning. So here, I'm going to bring an equal sign down, and I want to know what this is. I got to simplify it. So I'm going to do 4x squared multiplied by everything in here. So I'm going to just remind myself that I'm going to multiply that and that. If you don't need those arrows, don't draw them. I won't draw them the second time. So 4x squared times x to the 3. That's 4x. I add the exponents because I'm multiplying. 5. 4x squared times negative 2x squared. That's minus 8x, x to the 2, x to the 2, x to the 4. Plus 2x cubed times 2x to the 2. So that's 2 times 2 is 4. X to the 3 times x to the 2 is x to the 5, because I'm adding. I'm multiplying, so I add the exponents. 4x to the 5. And then 2x to the 3 times 2x. So this is plus 2x to the 3 times 2x. That's 4x to the 4, because I add. X to the 3 times x to the 1 is 4x to the 4. Now, I have some like terms here. I have 4x to the 5 plus 4x to the 5. So let's do that. That's 8x to the 5. I'm just collecting these x to the 5s. There's 4 of them there, there's 4 of them there, so that's 8 altogether. Just like if that's 4 apples, 8 apples. Same. Sorry if I sound angry there. It's so the same, but it's very different because this is x to the 5s, not apples. So I get it that it's weird. Negative 8x to the 4 plus 4x to the 4. Look, here's 0. I'm way down here at minus 8, and I add 4 to that. So I'm going to go up here to minus 4. Okay, so that's going to be minus 4x to the 4. Negative 8 plus 4 is minus 4. Okay, done. Final answer. Circle it. Next question. 2y squared times y to the 3 minus 3, blah, blah. You know how to read, so I'm not going to read it for you. 2y squared times y to the 3, that's 2y to the 5. I add the exponents together because I'm multiplying. 2y squared times minus 3y to the 5. It's 2 times 3, negative 3, that's negative 6. Y squared times y to the 5 is y to the 7. Whoa, that's a big exponent. Negative 3 times all this. So I want to take this negative 3 and do times y squared. So that's minus 3y squared. Negative 3 times negative y to the 5. So that's negative 3 times negative 1. That is plus 3y to the 5. Plus, because negative times a negative makes a positive. Now, I have only one set of like terms that I can collect there, this one and that one. So let's put them together. 2y to the 5 plus 3y to the 5 is 5y to the 5 minus 6y to the 7 minus 3y squared. I have to bring those down. They're still a part of my solution, even though they don't combine with other things. So I circle it, done, final answer. Very pleased with myself. Now, 8c. 3m cubed, well, I'm not going to read it. You know how to read it. So 3m cubed multiplied by 2m squared. This is 3 times 2 is 6. M cubed times m squared is m to the 5. I'm multiplying, so I add exponents. 3m times minus 5m. So that'll be minus 15, because 3 times minus 5 is minus 15. M to the 3 times m is m to the 4. And then 3m cubed times 3 is plus 9m to the 3. Minus 4m, this whole thing gets multiplied by all these guys. So minus 4m times m to the 4 is minus 4m to the 5. Minus 4m times 2m to the 3 is minus 8m to the 4. Minus 4m times negative m squared is plus, because that's the minus. So minus times minus is a plus 4m to the 3. Now I've got 3 different types of like terms there. So the m's to the 5s will combine. So 6 minus 4 is 2. So that's 2m to the 5. Minus 15m to the 4 minus 8. Well, that's minus 23, because minus 15 minus 8 is minus 23. M to the 4. Plus 9 plus 4 is plus 13. M to the 3. Circle it. Done. Final answer. Now I'm looking at that, and there's none that asks you to divide. So let's create another question here on the back. All right, I'm going to create an ugly question for you. Here we go. We're coming at 8 plus, so it's a very challenging question. Here I'm going to have 5x squared multiplied by 3x cubed minus 2x plus 7, all divided by 7x to the 3. Let's see what happens. Okay, so first I'm going to equal this, I multiply in, so that's going to be 15x to the 5. You know what? You guys don't need to know this yet. The reason why it's not in the textbook yet. Okay, yeah. I forget that you're only grade 9s. All right, so in question 11 on page 127, this is an application question, and there's a company. They own 12 sedans whose value is given by the equation negative 2,400x, where x is a number of years, plus 19,600, and they own 3 SUVs whose value is given by 3,100x plus 24,500. Okay, so every year that goes by, these cars and SUVs become less valuable. That's called depreciation. Bad news for people that want to buy a big, beautiful car on your 16th birthday. It's worth less money when you're 17. It's worth less money when you're 18. Buy a house instead, and that grows in value. Yeah, well, harder to buy a house when you're 16. But anyway, I digress. Let's carry on with this question, shall we? So 12 sedans, 3 SUVs. So we want a formula that shows all of this together. So the total value of the vehicles, the V total, is going to be equal to 12 multiplied by this. Negative 2,400x plus 19,600 plus 3 times this, plus 3 multiplied by negative 3,100x plus 2,450, end bracket. If I don't end my brackets, I mean, people will wonder what's next. They're waiting for the next thing to happen, and nothing's going to happen. End your brackets. All right, so now the value total. Now I can multiply these in, and then I can multiply that in. So I apply the distributive property. It's 12 times that, and then 12 times that. That's going to be, this is equal to negative 288. I think that's right. That's gotta be, that's right. Yeah, x plus this times that. Blah. There's a limit, people. There's a limit to what I want to do in my head right now, especially while I'm talking to you about all of this interesting stuff. 235,200. 235,200. Plus all this stuff, plus 3 times that. So plus, I'm just going to put it in brackets because I just noticed I'm going to have a negative there. So that's ugly. Oops. All right. 3 times that. Oh, that's easy. That's 9,300. It's negative, don't forget. And x plus 3 times that. Well, that's also easy. It's 73500, right? Let's just make sure. I can't be bothered to check it in my head. I just want to know. I think I'm missing a 0. No, I'm not missing a 0. That's right. Yeah, that's right. Okay. So yeah, so now I can remove this bracket because there's nothing to do inside that bracket. So because I forgot and I made a mistake there, I now need to write another line. 28800. Let's put a little comma in there so it's clear. X plus 235, 200 minus 9300x plus 73500. Now I can collect like terms. So I have my x's, which are both negative, and I just add them together. And then I have my constant terms, which are both positive, and I just add them together. So plus 235,200 equals. So there's how much. That's like the initial value of all the vehicles together was $308,700. It's expensive to run a business, isn't it, people? And then here, I'm going to do that. So 28800. Notice that's a positive number, and I'm going to add this one, 9300, and then I'm just going to change the sign. So it's negative 38100. Negative 38100x. So every year, the value of their vehicles is losing $38,100. Bad news for this company. I hope they're putting the vehicles to good use and making lots of money with them. So what's the initial value of the vehicles? The initial value is $308,700. Okay, that's how much they paid for the vehicles in the beginning. All right. How do I know that? Well, what time was it when the beginning happened? Well, it was 0 time. It was 0 years, or that was the 0 year when they bought them. So I put 0 in here for X. This is 0, and then that's all that I got. That's why I know that's the initial value of the vehicles. And then how much are they losing every year? They're losing this much. When I put in 1 year, I have to subtract that once. When I put in 2 years, I have to subtract that twice, because I'm taking that number, multiplying by 2, and then subtracting it from that. That's how that formula works. Now, how fast is each losing money? How fast are the cars losing money? Well, I know that the sedans are losing $2,400 of their value each year, each sedan. And the SUVs are losing $3,100 of their value each year. I just read that from the equations, and you're going to learn how to do that next chapter. Oh, the things you'll learn how to do next chapter. This is really useful, actually, the stuff you're going to learn next chapter. Okay, bye.
We wish you a great day.
Where's my off button?